welcome you once again to doctorate class. We have another problem here on concave mirror. Let's do this together, guys. A concave mirror of radius of curvature 40 cm forms a sharply focused image of a small object on a screen placed at a distance of 80 cm from the mirror. Determine A, the position of the object, B, the linear magnification of the image. Now this question came from a grade 11 learner, so I shared my idea with the learner. I decided to share it with us as well. Now, as always, I love this simpler idea of solving mirror problems. First, you sketch the situation. First thing to do is make a sketch of the question given to you. It will help you to have a picture of what is happening and make the best decisions to get it right. And this is very simple, guys. Trust me. Look at this. A concave mirror, right? We know this is a concave mirror. This is the back. This is the front, and that makes it a concave mirror. Light comes from this surface. Radius of curvature is the distance from the center of the sphere from where the mirror is formed to the pole. That is radius of curvature. Now remember, there is a circle here or a sphere. One part of it was cut out to make this mirror. So the center of that sphere is center of curvature. The distance from that center of curvature to the pole of the mirror is radius of curvature. The first thing you are going to draw is the principal axis, a horizontal line passing through the center of curvature and the pole. Now go to your pole. Say any horizontal distance measured towards the left is going to be negative. That's a sign convention. Any horizontal distance measured to the right is going to be a positive distance. Draw a vertical line from the pole. Any vertical distance measured above the pole is going to be positive. Any vertical distance measured down under the pole is going to be negative. So, because this is center of curvature, the radius of curvature is 40 in front of the mirror. So it means our radius of curvature in front of the mirror is towards the negative x-axis. So it's going to be minus 40 cm. Do you remember that expression that focal length is half radius of curvature? So we can use this to know the value of our focal length, which is minus 20 cm. Because 2, cancel this here, cancel this 2, cancel this 0. So we have minus 20. Of course, image distance is the distance from where the image is formed to the mirror. From the question, it was 80 cm. Now, what sign should we give it? A concave mirror, we know, forms image that is real in front of the mirror. Now, if your positioning is wrong, when you calculate, it will come out. So I will put this minus because it is actually formed in front of the mirror. And again, the question said the image was formed on the screen. Images formed on the screen are real. Had it been, it wasn't formed on the screen, that means it would have been virtual behind the mirror. For it to be formed on the screen means it was formed in front of the mirror. Okay, that's very, very key to we solving this problem. Now let's go and solve the A part. It says the position of the object. Use mirror formula 1 over f equal to 1 over v plus 1 over u. Now let's substitute 1 over, what's our f? Minus 20 equal to 1 over, what's our v? Minus 80 plus 1 over u. So I'm going to have 1 over u, making it subject. I'll take minus 1 over 80 to this side to collect like terms. So I'll have minus 1 over 20 plus 1 over 80 can continue here. 1 over u is equal to, I take LCM of 20 and 80, that is 80. 20 divided 80 is 4. 4 times minus 1 is minus 4, plus 80 divided 81. 1 times 1 is plus 1. So have 1 over u as minus 3 over 80. So invert this to get u. We invert this as well to get minus 80 over 3 cm. To put it in decimal, you divide on your calculator 80 divided by 3. You have u as minus 26.7 cm. Now, why do we have minus? Minus tells us the object was placed in front of the mirror. Remember, in front of the mirror is negative x-axis. Of course, if you put the object behind the mirror, you won't even see. The light from it cannot fall on the mirror, so there's no chance to get the image. So that agrees with our earlier decisions considering the screen. Now let's go to the B part. Say we should find the linear magnification. Remember, we're using the sign convention. This pattern is always very easy and simple. Magnification is minus V over U equal to, put the minus sign. What was V? Minus 80. Minus 80 over U. We got U as minus 80 over 3. Now look at the easiest way to express that. Minus times minus 80 is plus 80 over 1 divided by minus 80 over 3. This is plus 80 over 1. Change the division to times, you invert this fraction. Minus 3 over 80. 80 will cancel 80. You have minus 3 over 1. So the magnification is actually minus 3. What does that mean? The image distance is actually 3 times farther from the mirror than the object distance. Or you say the size of the image is 3 times bigger than the size of the object. Now, what is the essence of the minus? It means the image was inverted. If the object was standing upright, the image was inverted, pointing down. If the object was pointed downwards at the beginning, it means the image was standing. That's the essence of this. Thank you so much, guys. I hope you learned something simple and easier on how to solve questions on mirrors. The next videos I'm going to make is going to be on calculations involving convex mirrors. And guys, I'd like you to watch these videos. Tell me, make your comments, your observations, and feel free to learn more from Dr. Ray. Thank you.